Okay, so here's our last question today. This is going to be an elastic collision. These ones, we can actually solve them using a lot less data, because if we know that energy is conserved, we have a whole second equation that we can solve for. So we can actually solve for a scenario with two unknowns instead of just one, like the previous ones. So it says a 1 kilogram ball is rolling to the right at 3 meters per second. So we have a ball rolling to the right. And we have another ball. This ball is moving to the left. They're going to collide, and we don't know where they're going to go, but they're going to have some velocities. Maybe the first ball is going to continue moving forward. The other ball might move forward. We're not really sure. We're going to solve for those velocities right now. Okay. So initially we have some mass. So they have 1 kilograms. So P is equal to mv. 1 kilogram. We're going to get long numbers, so I'm not talking about units in this one because I'm unable to write small using this drawing tablet, so it's just going to take up a lot of space with all those units. Or the proper way is to write down all the units. Here we go. So 1 kilogram traveling at 3 meters per second. 1 kilogram times 3 meters per second. Plus, the other one is 2 kilograms and it's traveling at 1, but to the left. So it's negative 1. Later on, we have, it's still 1 kilogram, but we have some unknown velocity of that block, and call that V1. And we still have that 2 kilogram ball, but has some unknown velocity, V2. So right now we can't actually solve for a value. However, we can see that we get 3 plus negative 2, we get 1 is equal to V1 plus 2V2. So we have a linear equation. Okay. Can't solve for it. So now we have to recognize that kinetic energy is equal to 1/2 mv squared. So when we write this out, so okay, object's 1, 1/2, mass is 1, velocity is 3, we're going to square it. Mass is 2, velocity is 1, we're going to square it. It's negative 1, but I don't really care because that negative is going to become positive when we square it. That's equal to 1/2 v1 squared. That's 1/2, that's 2 v2 squared. Now, because I don't have a 1/2, I can simplify that out, and that's going to go away. So I end up with 1 times 3 squared, that's 9, plus 2. So I got 11 on the left side. 11. Let's get black. 11. Now on this side I have v1 squared plus 2v2 squared. So I have a second equation. This one's not linear though. So to solve this, we're going to have to do a little bit of substitution and a bit of math. It doesn't matter which one we do. We can plug in for v1. Let's try that. So this one, I can rewrite this equation as v1 is equal to 1 minus 2v2. Okay, so v1 is equal to 1 minus 2v2. So I'm going to take that and plug it into v1. So I end up with 11 is equal to, so I'm replacing v1 with 1 minus 2v2, squaring it, plus 2v2 squared. So now I have to expand that bracket. We got 1 minus 4v2 plus 4v2 squared plus 2v2 squared. If you don't remember what I did some foiling. So first 1 times 1, then 1 times negative 2v2, then minus negative 2v2, then I get plus 4v2 squared. Okay, so that's all I did right there. Now we're going to group like terms, so I get 0 is equal to, I have a total of 6v2 squared minus 4v2, and it looks like minus 10. So now this is just a quadratic equation. So we can go ahead and solve for v2 now. Alright, quadratic formula is we're going to have v2 is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. So b, let's do the thing inside that square root first. So our b term is negative 4. So I get 4 plus or minus the square root of, so we have 4 squared minus 4 times 6 times negative 10. So 256. Square root 256 is 16. So we get 256 over 2 times 6. So we get 4 plus or minus 16 over 12. So when you see that, we have 4 plus 16 divided by 12. You get 1.67 meters per second. Or we get 4 minus 16 divided by 12. And negative 1. So one of these answers is our correct answer. The other one is not. So one way of knowing we actually did it correct, we don't actually get the original speed of v2. So the original speed of v2 was negative 1 meters per second. That's the original. So this must be our actual value. So v2 is equal to 1.67 meters per second. And it's positive, telling us it's moving right. So it actually collided with the first ball, and it's now originally moving left, now it's moving right. Now if I take this value and plug it into either of my other ones, so v2, so 2 multiplied by this answer, so I have 1.67, or I can keep more digits, multiplied by 2. I have 1 minus that value. So we actually get v1 is equal to negative 2.34 meters per second. You should be able to plug in either one. This is one way of checking your work. So 1.67, if I square that, times by 2, 11 minus the answer, square root, and yeah, I got the same answer. Well, I got 2.33, so slightly off because of my rounding of 1.67, but we get the same value. Again, if you plug in the energy, if you plug this energy one, you have to be careful though, because when I find these square rooted, we get a value of v1 squared is equal to, we got a value, a number, but when we square root of both sides, we recognize we have that plus or minus. So the actual value is at negative 2.34. And we are done this question with. This is our velocity. So a little intensive in the math, but this is grade 11 math, so it's totally doable.